what's next, time of use rates. This is something that could happen in the next 5 to 10 years where members are charged a higher rate during those peak times and a lower rate during off-peak times. You know, midnight to 6 in the morning is really cheap electricity. And another thing you'll probably see along with the time of use rates, smart home, smart grid, meters being a gateway to your home. And smart appliances, smart thermostats, that when we're on that higher rate, your appliances and your thermostat understand that. And they may make the decision, do I really need to run to cool the house at this peak time, or can I wait 1 more hour before I kick the air conditioner on?
Couldn't there be a way to capture electricity though and use it for the
Storage?
Yeah.
Not with the battery technology where it's at today, but it's something that I know is being studied all the time.
If you can help solve that problem, you wouldn't be sitting in this room.
Yeah. If we could store power, you know, from midnight to 6 in the morning and then use that during our peak times, that would be ideal. You know, an example of that is the Tomsock Dam.
Water storage
that Ameren has. You know, they store water in this lake up high, let it run through their dam, and then pump it back up during overnight when the power's cheap. One of the next technologies we're using heavily, and I know a lot of you are county commissioners, you're probably familiar with GIS systems.
In fact, several of them have partnered with us on our base maps.
We've got a lot of data from the counties. And the GIS system is going to enable us to improve our outage management. Currently, we're going through a complete field inventory of our system. We have crews out on our system with video cameras going to every one of our poles, all through our 4,000 miles of line, collecting sub-meter GPS coordinates. They're making an inventory of every device on our system. It's building a complete database, a model, a graphical layer on our GIS system. The goal of the GIS is obviously for our outage management, and to keep this data up to date, we've had to deploy, we call it electronic staking. It's our engineers in the field have a staking tablet and a GPS unit, and they actually draw and design the lines on their tablets electronically, and then come back into the office and refresh our GIS database. With our GIS, we can detect and pinpoint outages in our system. We will have real-time maps in our trucks that can reflect outage information. We can give them those outages in real time. We can predict outages on our system. This GIS system will map our fuses and our breakers, and then we know where they're at and when they're open or where they're closed, and that will tell us, again, help pinpoint outages, get the power back on quicker.
What was that bottom integration with IVR phone system? What does that mean?
We are installing a phone system and an IVR system here in the office the first of next year. And what will happen is you can call in as a member. It will detect your phone number. You can say press 1. If it's after hours, you can say press 1 for an outage. It will automatically update our outage management system. It will begin the process of dispatching crews. Our AMI system will kick into gear then, and will start pinging meters around you to try to figure out if it's just you or if it's the whole line, and then it will graphically update our system. And then the next person that calls in, if your whole line's out, if they call in, it will say we're already aware of your outage, and we have crews dispatched. It'll save a lot of workload on our customer service staff. And of course, asset management. I know it will help a lot with tax assessments and things like that as well.
So then, if you have access to the web, you'll be able to see a graphical representation of where the outages are.
We should have a graphical representation of our outage management system when it's fully in place in about 18 months.
Available to the members.
These are just some screenshots of our GIS system. Some of the areas we've already had mapped. This is kind of the outage management process. I already talked about the IVR. We can also detect by meters pinging. That's what pinging of the meter is. We send a signal out to the meter and then it sends a signal back. If it doesn't respond, we're assuming the power is out at that location. We also have some smart breakers on our system. We should have the capability of, when that breaker opens, it sends an immediate signal into the office and updates that map immediately. Once that outage is initiated on our system, then our AMI system kicks in and can ping those meters to try to just determine and predict the extent of that outage. And then it will update our map, and then that gets dispatched out to our crew. Our crews all have laptops in their trucks now, and once they get that ticket sent to their truck, then they can go restore the outage, complete the outage ticket, which then updates our system back here at the office in real time. And then again, the AMI system again kicks in and starts to ping those meters to make sure the power has been restored. In addition to that, our IVR system can call back and say, John, you know, we're aware of your power outage. It should be restored. Press 1 if it has not been, and then we can check in further.
So they'll be able to do the, complete the outage ticket from their truck and
Yes,
wirelessly send it to,
and it wirelessly comes back. And that brings me to the mobile workforce solution. As of yesterday, all of our maintenance trucks have one of these military spec rugged tablets in their truck with a Verizon cellular data connection back to our office. And they receive their service orders. They will be able to, sometime next year, receive their outage tickets, and things will be delivered to their truck computer. And this is just a picture of the training we went through on Tuesday with our linemen. In addition to the mobile workforce, we also have automatic vehicle location. We have GPS units in the truck, so we can tell where all the trucks are at any given time for dispatch purposes. As I said before, you can initiate and complete service orders without paper. We have real-time maps in the trucks, outage tickets dispatched, restored electronically, live vehicle locations. Crews can actually interface with our AMI system now and can ping meters. So if they go restore power down a line and they come back to the substation to close the breaker, instead of having to drive back to verify that they turn the power back on, they can actually ping that meter from the truck. Saves them time. We do have electronic versions of our maps in the trucks now. And they can also see all the consumer information. And the AVL system helps with routing and assignment of service calls. If we have an outage come in during the day, somebody can pull up our vehicle location map and pick the closest truck to dispatch to that outage. And this is just a screenshot of our vehicle location map. Each one of these are a truck. Down here some status. You can see their speed they're traveling. You can see if their power takeoff is enabled, whether they're running their hydraulic pump.
There's much wilderness areas in that area. How is it hard to get communication in some areas where trucks might be, or like cell service isn't good in some areas with lag again?
Yeah, there's some areas in our system that are holes, and what happens with this system is the device in the truck still every minute records their coordinates where they're at, and then as soon as it gets back in coverage, it transmits that hole.
Okay, so they could be in an area where they just don't, they're not covered.
But we have external antennas and things on our trucks, and it seems to help a lot with the coverage.